So what is this thing called SDLC, or Software Development Lifecycle? Assume that you're working for a company which is involved in developing software application for clients. So what happens, the business or the sales people, if we have to call it in a raw manner, the business brings in an order along with the specification. So whatever the client requires to be developed as software, that is all found out. The business gets the order and the requirements are given to the design team. So the design architects, all these guys come together and design what is to be done and then pass it on to the programmers who do the coding. Once it is built, then testing is done before it is actually deployed. After deployment, then it is being monitored for production. In the sense, what happens is users start using it, there could be complaints, there could be feedbacks, there could be feature additions that are warranted. All those will have to be monitored. If the performance is okay, whether the load is overloaded or what, all these also have to be monitored. And if there is a feedback, if everything is fine, all right, if there is a feedback, then the whole thing is given back as input to the design team or the coding team as appropriate, and the changes will have to undergo this life cycle all over again. So what happens is the entire cycle goes step by step, right from the information gathering, designing, implementing, testing, deployment, and thereafter, once everything is running fine, maintenance and monitoring. Okay, now what happens in this process? There were some challenges. What are those challenges? The business which brings in the order passes it on to the design development team, which designs, develops in its own environment. Once it starts functional, then they give it to the operations team, which is the infra team, which is predominantly guys like us. And the infra team runs it on a production environment. In fact, there will be a pre-production on which it will do a test run, and then if things are fine, it will run it in a production environment. What used to happen was there used to be a difference between the environment on which these guys are developing the whole stuff and the environment where these guys are deploying. Maybe there's a small version difference in one of the components, and that is creating dependency issues. And so this guy would say, hey, whatever code you have given, it's not running. He'll return it back. This development guy would say, it's working perfectly fine in my environment. Something wrong with you guys. They put it across to the operations. And this used to be a wall of conflict. And DevOps evolved to fix this wall of conflict. Right? They said, we're not going to work independent of each other. We're going to work together. Development and operations. And that's when DevOps was born. This is point number one. Point number two, vis-a-vis the architectures of yesteryears, which was monolithic in nature, vis-a-vis the stability or the standard outcome of a web application which did not warrant much of change once it is implemented earlier on, today the demand is much different. We're going to see those architectures, and changes are here to stay. Where there were one or two changes once in few months or years, today there are few changes every day or every week. They have to be implemented. So that's going to be a huge bottleneck. Every time you keep on changing something, features to be added, faults to be rectified, continuously the development team keeps on doing this, and production will hardly work. The operations would stop. So that also they decided to address in the DevOps. So it's a matter of culture. The culture of both the development and the operations team understanding that change is the new normal, and we'll have to embrace change into our development as well as infrastructure and also get ready, prepare for a continuous stream of changes. So the development, operations, quality, which is testing, and what is left out here, if you want to add security, all these go into DevOps with a great degree of automation. If the automation were absent, then this were not possible. Right. So what is the evolution? Did it jump from the original model where it was a stage-by-stage process to the new continuous change process, automation process? No, not really. There was a step in between. The original software development lifecycle was called the waterfall model, wherein after the requirements were understood and design is ready, developers started working. So this team is idle. Test team, deployment team is also sitting quiet when the developers are developing. Let's say they take 3-6 months, and after that they hand it over to the test department. These guys say something has passed, something has failed, feedback comes. So these guys start working on that. And then finally, once everything passes, the deployment guys or the operation guys come into the picture. So this was not found to be really efficient with the changing environments. So they embraced the agile model, wherein they broke down the entire piece, the huge piece, into smaller chunks. And they said, let's finish module by module. Let's have regular meetings. Let's have regular completions. And once one is done, then we go to the next, which was much, much better. They were able to release the products, versions, changes, etc. much faster. And then it goes to, once everything is ready, it goes to the deployment team for deployment. But then still it did not accommodate the kind of fast change that was warranted in today's environment. What is that? That is a few changes to be released, incorporated on a daily basis. Feature has to be added. The developer has to add that feature, and immediately it has to go live at ASAP. It has to be, of course, going through the entire cycle of testing, quality, smoke test, operational viability, everything it has to be done, and then it has to go live also. That's when they decided this particular aspect of automating the entire process. All the stages that are involved has to be done automatically. Unless and until there's a manual intervention where a developer is involved or a manual approval is involved, everything else is automated. So what happens? Whenever a developer makes any change, he uploads the changed code, the whole DevOps component, set of components, integrated set of components would pick up the new code, build a new environment, test it automatically, and deploy it in the infrastructure. Monitor. If it finds a fault, give a feedback, and the developer starts all over again. So in this case, what happens is if the developer wanted to add 3 features in one day, he can keep on adding, keep on uploading the file, and the DevOps automation would take over till deployment. That is the advantage of DevOps. Right. So before I go much further, let's try to understand the new environments, the new architectures that also need to be known, because DevOps has to accommodate all the new architectures. So a couple of new names, no longer new to be frank, but nevertheless I would like to mention here, are the serverless and microservices architecture. Now, what do we mean by this? What is serverless? Sounds a little intriguing. Before I go there, let's understand the change in the type of software design. Earlier on, when they built applications, they were monolithic in nature. What do we mean by that? Everything was built as a single package, right? The user interface, the business logic or the business intelligence, the data access, they will connect to the database where the data is stored. All this stuff was built together as a single monolithic application. With time, they figured out that why should the business logic have any dependence with user interface? Why should the data access layer be coupled with this? If everything is coupled together, any change in the user interface will impact the entire software. We'll have to change code everywhere. So they decided to break this down into different independent units, which is what is referred to as microservice. So I may say that this is the user interface microservice, this is the business logic, this is the data access layer, so on and so forth. I'm sorry, this is not the user interface. The user interface is the integrator. So whatever tools you require, all these tools are, I wouldn't call it tools, modules. All these modules are developed and integrated in a single front-end user interface. Let me imagine like this. I'll give you a small example. Let's say you're going to go into the income tax IT returns filing. So when you log into the portal, the first thing that happens is you need to authenticate yourself. So I may have an authentication service. After that, you fill up the income tax returns, IT returns form. The form will have a calculation where it computes your income tax. So that would be another microservice. And a third could be the one which validates and generates an acknowledgement. That could be a different microservice. So if you log into any portal, the portal is a single user interface where multiple functions are integrated together. Right? So this is the microservices architecture. And if this were not sufficient, you have the new, thanks to your public cloud, you have the new environment called the serverless architecture. Originally, we had the monolithic architecture, which had a multi-tiered application with a web server, application server, database server, three-tiered architecture. And then came on your microservices, where there was a single user interface which combined different microservices. And that's precisely why and where your Docker container, Kubernetes kind of stuff comes in. And today, thanks to your public cloud, your Lambda function, Azure function, Google function, you have this serverless architecture, wherein you literally do not have any hardware, any virtual machine, any container which runs your language or program environment. You simply pass on the code to your AWS Lambda, it executes it and gives you the result for you to consume, use. So that's the era we are into. So if you look at the various available platforms today, how do you deploy your application? Historically, you did it on physical servers. You bought hardware, installed the operating system, your runtime, whether it is Python or C# or .NET or Java or whatever, and then whatever application you want to build, the runtime dependent libraries or DLLs, and then you have the actual code which constitutes the application. Then came in the era of virtualization, where virtual machines were used to do exactly the same thing. Hardware was released and you started working only at these layers. And finally, what happened? The microservices started kicking in. So each portal, let's say, now since the functionality is divided into smaller units of microservice, I can have one functionality built on Java, another built on .NET, a third on Go language, a fourth on Python, and I can bring them all together. So what happens? There is a common base. On the hardware, you have an operating system, and on the operating system, you have something which virtualizes the operating system and allows you to create multiple independent containers. This will help with the Java program. This will be a Node.js. This will be Python. This will be Go language. so on and so forth. So you're freed up of the other layers and you're working only on the top layers closer to the application. You want to free up yourself with everything. You don't even want to manage this stuff called containers. Then you have your AWS Lambda, Google or Azure functions, wherein you simply pass on the code, this fellow will execute and give back the results to use. So applications today are built around all these available platforms. And depending on the type of application, not everything would be suited for every environment. So today you have a mix of all these. Probably the same portal, you may want to have some components installed on a virtual machine, some component would be containerized, and some other component, like I told you in the income tax form, the forms may be running on a certain platform, maybe that's on a particular container. Whereas when it wants to compute, it's only mathematics. The compute may be a code, a calculator code may be present in the Lambda, and for computing, all the values will be passed on to this code, which is working on serverless environment, and the results would be filled up. And probably it could be a 3-tier architecture where your web server, all that also exists for database, etc. So VMs might also be used. So in a given environment, you have a mix of all these three, which means if I'm embracing DevOps today, I need to understand that it could be monolithic or a microservice. It could be virtual machine, container, function. It could be any of these. So here's a small example. You might still be wondering how a serverless web application might work. A user logs in to the portal, right? And there is one AWS component which is going to host all the static information. Okay, it might be running a JavaScript, all right. Otherwise, it could be your HTML, CSS based web pages which are available. So this guy has to log in to perform a certain function. Assume this is an e-learning portal. So for login authentication, there is another component, Cognito, which helps with authentication. And finally, once he authenticates himself, he accesses the pages, he selects the course that he wants to do. The content is stored possibly in a DynamoDB, a database. So he uses an API based on what he has paid for, what he is allowed to access. Maybe he can access 4 or 5 set of videos. He chooses one, and that is passed on to Lambda function through what is called as an application programmable interface. And the Lambda function executes the code to build, to showcase the environment from where he can pull the data, stream it, view it. You can see that nowhere there is presence of anything like a virtual machine, EC2 instance, etc. Nothing. You have a database, you have these things stored in AWS Amplify, or you might also want to choose S3, Amazon S3, and you just have the API gateway functionality of Amazon being used to access content from the database with the help of Lambda. So this is an entire serverless architecture that you get to see here. Similarly, if you're looking at another example, let's say you're trying to browse e-commerce portal like Amazon itself. So the moment I'm just going to highlight how the microservices, containerized microservices help. So let's say you go to the Amazon website and you wish to buy a mobile phone. So what you do, you first log in so that you can place an order. And when you do log in, it immediately sends out the information via API gateway. And in a containerized environment, the identity microservice is running. That authenticates you. And you are now logged in. So the next, you try to figure out the available models of mobile phones. Immediately, when the search criteria is entered, the catalog service offers you a set of catalogs of choice of mobile phones. And once you have zeroed in on the product that you wish to purchase, you add it to the cart, and again, that sends a request to a different microservice which caters to ordering. So in this example, you can very clearly see that you have different functionalities delivered or executed by different components, different microservices. This is called a microservice because each is independent of the other and it's not a huge monolithic application. They might be small codes. And each of the microservice application runs in a containerized environment.